trouble. All right. So if you can get out your little worksheet, the diameter of the field of view worksheet that you're going to be turning in by the end of lab. Hopefully you had a chance to look at it. Hopefully you did the practice problems there, the first couple of problems. And what we're going to do is walk through how you're going to calculate the diameter of the field of view for all four of your objectives. It's very important information. The first thing everybody will need to complete your homework is that you'll need to come up and get a metrics ruler. Okay. These are community rulers, so please return them when you're finished. Make sure that you, with your teammates, you make sure that you know the difference between the English system that has inches and the metric system, okay, that has centimeters and millimeters, okay, because you're going to need the metric scale. And what you're going to do is, when you retrieve your microscope, and I'll just borrow one from over here. We are going to measure the diameter of the field of view with our scanning lens in place. Now, what do I mean by diameter of field of view? The field of view is the area of the slide we can actually see when we're looking through the oculars. Okay, so when I look through my oculars, I only see a tiny portion of my slide, right? Okay, so that part of the slide that I actually see is called the field of view. The diameter is the distance from one side of the field of view to the opposite side through the center point. That's called the diameter. Okay, so I've just drawn a line here to show the diameter. So this would be the diameter. If this represents my field of view, that's the diameter. I want to know the diameter. I want to know how many millimeters that is. So if I have really large cells, I could estimate the size of an individual cell. And the second reason I want the diameter for my scanning lens is I'm going to use that value. I'm going to plug it into this equation so that I can calculate the diameter of the field of view for all the higher objectives. Now, why do we have to use math? You know, it's like, Well, the reason is, what happens to the diameter of the field of view as the magnifying power of your objective lenses increase? Is it going to get bigger or littler? Smaller, right? Now, some of you may have seen under the shared lab resources in D2L, I made this little table that describes characteristics of your four different objective lenses. Okay, so that might be useful to download. And it has a cartoon of what happens to the diameter of the field of view and the diameter of the lens of the objective lenses as we go from low power to higher power. The diameter of the lens itself decreases, and thus the diameter of the field of view decreases. So, you know, so what? What does that matter? Well, the reason we can't use a ruler to directly measure the diameter of the field of view, say for the 40X lens and the oil immersion lens, is the diameter of the field of view is less than 1 millimeter. There's no way for us to measure it using our metric rulers, right? That's why we have to use these mathematical equations to get there. Okay, so let's do an example. Let's presume I've got my metrics ruler on the stage of my microscope. Okay, I'm going to focus on my metrics ruler just as if it was a slide. So my scanning lens is in place. I look from the side. I use coarse focus adjustment. I raise the stage all the way up. Okay, and then I'll look through the oculars, and I'll focus by lowering the stage. Okay, so that's just what we do all the time. So I'll get my ruler into focus with the scanning lens. What I want to do is I want to move the ruler so that one of the units is right on the edge of the field of view. And then I'm simply going to count the units. How many units does it take to span the diameter here? Now, what are these units, you guys, on our metric rulers? What are the smallest units? 1 millimeter, right? Okay, so I just made a cartoon. I'm going to pretend this is what I'm seeing, my ruler. So what's the diameter of the field of view in my cartoon field of view? So I just count, right? 1, 2, 3, 4. What do you think? Maybe you're at 4.5 millimeters. Would you agree? 4.5. So we'll say, so with my 4x objective lens, the diameter of the field of view is what?
4.5.
We'll just go ahead and make our lives easier. Say about 4.5 millimeters. You okay with that? Okay. Now, these values, you guys, will never change for your scope. Okay? And remember, you guys, you need to measure this yourself on your microscope because yours might be different. Once you've measured the diameter of the field of view with your 4x objective, it will never change for your scope. So these are constants, right? 4x is constant, 4.5 millimeter is a constant. So how will we use those constants to calculate the diameter of the field of view for your 10x or 40x infinite immersion? Okay. We're going to use this formula, D1M1 equals D2M2. We're going to rearrange it. So this is kind of key right here. I'm going to rearrange it. Okay, and let's just walk through what these values are. D1 is the diameter of the field of view for your 4x lens. Remember, that's constant. You measure it with your ruler. M1 is the magnifying power of your 4x lens. Okay, so let's plug these in. So for this cartoon, you guys, what's D1? What's the value of D1? 4.5. Dynamite. 4.5. That's not going to change in my cartoon. What's M1? 4x. That's not going to change, right? Okay, so those are constants. Now what will change is this M2. M2 is the magnifying power of the other objective lenses. So let's do the calculation for the low power lens. What is the magnifying power of my low power lens? 10x, right? Okay, so I'll put 10x in here. And this is my unknown. What is D2, do you think?
Diameter of the 10x.
That is right. This is what we're solving for. This is the diameter of the field of view using the 10x lens. Does that make sense? Wow, that's not too bad. Now it's just math, right? So 4.5 times 4 is 18. Okay, so that's 18 millimeter diameters divided by 10 diameters. The diameters cross out, right? They cross out there. So 18 millimeters divided by 10 is what? 1.8 millimeters. Now this is always the problem, you guys. You go to all this work and you're like, so what is that? So what is that, you guys? What is that 1.8 millimeters? Why was I doing this?
Diameter of the 10x.
That's going to be the diameter of the field of view using your low power lens, right? Okay, and that's what happens with all these equations. Diameter field of view using 10x, right? All right. How would you calculate the diameter of the field of view using your high dry lens, your 40x lens?
Exchange the 10x to 14.
Okay. In this equation here, you guys, would I erase 4.5?
No.
Would I erase 4?
No.
Would I erase that?
Yes.
That's what I would change. That's the only thing I'm going to change. If I want now to calculate diameter field of view for my high dry lens, I just put in 40x. I do the math, and I'll end up with
4.5.
I'll end up with 0.45 millimeters. Okay, and that'd be the diameter field of view for 40x. And then you would just do it one more time for the oil immersion lens. The only thing you change is you're going to put what down here? 100x, right? Okay. So by doing the actual measurement for the 4x, you get your diameter of the field of view. Then you run the calculation 3 times for the 3 other objective lenses. You should have, by the end of lab, your diameter of field of view for scanning, low power, high dry, and oil immersion. That's what you're going to write on the back of your worksheet, and you're going to write it in your lab manual or lab notebook somewhere where you can find it. Now, last thing I promise you, I know you're just like, oh gosh, this is going on forever. Okay, so why is that useful? Why is that useful? So let's just do a real quick